Hello students, in today's class we shall discuss the mole concept. So usually students feel the mole concept very difficult, but understanding the definition of the mole concept and its formulas will give you an edge while solving the questions. Let us try to see the mole concept today, and we shall take some examples also and apply the formulas to those examples. So which will give you an edge over understanding the concept of the mole, and it also helpful for you in solving the questions. Now let us see that. Concept of mole. Let us see the definition of the mole first. Any substance that has as many number of particles as present in 12 grams of carbon-12 isotope called 1 mole. So the definition is actually a comparison definition. Here particles stands for, it may be atoms, molecules or any microparticles. You take any substance that has as many number of particles as present in the 12 grams of C12 isotope. Whatever the number of atoms present in the 12 grams of C12 isotope, that number is called the 1 mole. And if any substance is having the same number of particles, that substance is also having 1 mole of the particles in it. Imagine if 12 grams of carbon-12 isotope is having only 2 particles, then this substance, if it is having the 2 particles, then it is called the 1 mole. If 12 grams of the carbon-12 isotope is having the 100 carbon-12 atoms, then if this substance is also having the 100 atoms, both are same number, then this is said to be 1 mole. So 1 mole is not the practically measured value, it is only assumption value, it is only expected value. It is a more proper value which helps us understand while solving the questions. So let us try to see how many number of particles are present in the 12 grams of carbon-12 isotope. So 12 grams of carbon-12 isotope contains 6.023 into 10 power 23 number of carbon-12 isotope atoms. If any substance that is having the same number of particles, then it is called as having 1 mole of the particles in it. So from this it is very clear that 1 mole, therefore we can take the 1 mole is equals to 6.023 into 10 power 23. This is the number. This 1 mole usually represented by the symbol small n, whereas this number is also known as the Avogadro's number. Avogadro's number representation is Na. So when you are using the number, we use this Na symbol, or when you are using the word, then we use the letter N to represent the mole. So let us see some examples. Wherever 1 mole is there, you can use this number. Example 1, 1 mole of sodium atoms. That means 1 mole means what is the number? 6.023. 6.023 into 10 power 23 number of sodium atoms. if you take 1 mole of H2 molecules, that means again 6.023 into 10 power 23 number of H2 molecules called as the 1 mole. Similarly, 1 mole of electrons, so that is equals to 6.023 into 10 power 23 number of electrons. So that we can understand 1 mole can be applied to the atoms, molecules or any microparticles. You can take the ions also. 1 mole of the sodium ions means that is equals to 6.023 10 power 23 number of sodium ions are called as the 1 mole again. So mole is just a number that can be applied to the any concept. It means any number of any type of the atoms, molecules or ions or microparticles. Now let us try to see here what other information this mole is giving and what other information we can derive from the same part. The mass of, if you take the mole, 1 mole, mass of 1 mole of the molecules, mass of 1 mole of the molecules is called as its molecular mass, or it is also known as the gram molecular mass. So whenever we are calculating the molecular mass, we calculate molecular mass only for the 1 mole of the molecules. For example, molecular weight or molecular mass of oxygen is equals to 32 grams. This 32 grams means that 32 grams per mole always. So 32 grams is the mass of how many number of the oxygen molecules? 6.023 into 10 power 23 number of O2 molecules. Mass is how much? 32 grams. So whenever you are representing the molecular mass is nothing but the mass of how many number of the molecules? 1 mole of the molecules. That's why wherever molecular mass is given, indirectly they are giving the information about the number of molecules also. And for gases, this is only for gases. At STP, the volume occupied by 1 mole of the gas molecules at STP is called as the molar volume. This molar volume usually we take it as 22.4 liters using the atmospheres at STP conditions, 22.7 liters using the bar as the units pressure. So in NCR textbook both were used. For states of matter thermodynamics they have taken the 22.7 liters even for equilibrium also, but in organic part they have taken the 22.4 liters, so that we can take both either 1 atmosphere or for at 1 atmosphere or 1 bar, 22.4 liters, 22.7 liters respectively. So there is no much difference in the value, only 0.3 difference is there. So let us take example here. At STP, 1 mole of CO2 contains how many number of the particles? 6.023 into 10 power 23 number of CO2 molecules. And these many number of CO2 gas molecules at STP when you take the 1 atmosphere. So in the entire calculations, I will take the 1 atmospheres only. So that's why I will take the volume as the 22.4 liters. So at STP, 1 mole of the CO2 contains these many number of the molecules, 6.023 in 10 power 23, and these many number of the CO2 molecules occupies 22.4 liters of the volume. So that when you connect all these mole number, mass and the volume, we get the concept that 1 mole basically is equals to 6.023 into 10 power 23. These many number of the molecules mass is called as the molecular mass, and for gases these many number of the molecules occupies 22.4 liters of the volume at STP. So these are the mole. Now let us see some other connected concept to the mole. Afterwards we shall go to the how to solve the questions using the formula. So that is atomicity. Atomicity means the number of atoms present in making 1 mole of the molecule is called its atomicity. Whatever the number of atoms are participating in making of 1 mole of the molecule, that is called as its atomicity. Let us take some examples. So it is of different categories. Monoatomic molecules. Second one is diatomic. Third one is triatomic. And fourth one is polyatomic. So monoatomic molecules or atoms mean they contain only one atom. Example, noble gases. Noble gases exist individually. So you know that already helium, neon, argon, krypton, xenon, all these are gases. Radon we are not taking, which is a radioactive element. So they exist independently having the single atom. That's why they are called the monoatomic. Diatomic means these are having the 2 atoms in making of the molecule. Example, take the H2. It contains 2 hydrogen atoms while making the H2 molecule. O2, 2 oxygen atoms. N2, 2 nitrogen atoms. Cl2, Br2, etc. So these are all having the only 2 atoms. Even here we have taken the elements. You can take the compound also, molecule CO, carbon monoxide. Carbon monoxide is also having the 2 atoms. One is carbon, one is oxygen. Triatomic. These are having the 3 atoms in one molecule. So example, take the CO2, SO2, N2O, ozone, etc. So the molecule which is having the 3 atoms in it is called as the triatomic molecule. Polyatomic means the molecules which are having the more than 3 atoms are called as the polyatomic molecules. Let us take them. Phosphorus, P4, it is a tetraatomic. Sulfur, S8, it is an octaatomic. Now let us take NH3, ammonia. It is having the 4 atoms, 3 hydrogen atoms and 1 nitrogen, totally 4 atoms. So it is also tetraatomic. Let us take the PCl5. 6 atoms are present. 5 are the chlorine and 1 is the phosphorus. Hexaatomic. So all these are called the polyatomic molecules. So we need the atomicity while solving the sum of the questions, while calculating the number of the particles. That's what atomicity has been discussed now. So this is the mole. Now let us see how to use the formulas in solving the questions and how to develop the formulas to solve the questions easily. So formulae to calculate mole and its respective concepts. Wherever mole is involving, that concepts also we can solve. So here let us take, because while solving the mole we have seen that number was involved, mass was involved and volume was involved. So let us divide this mole problems in three categories: mass problems, number problems and volume problems. So when mass is given, how to solve the questions of the mole? What is the formula? Number of moles equals to weight by molecular weight of the substance. All these units must be in the grams. Or else, if atoms are given, so weight of the atom divided by atomic weight in grams. So that is the calculation of the mole. N equals to weight by molecular weight. Second, when number of particles given, then formula of the mole is given number of the particles divided by Avogadro number 6.023 into 10 power 23. Next, when volume of the gas is given, then number of moles equals to given volume in liters divided by 22.4 liters. If you take the milliliters here, it becomes 22,400 milliliters. Now let us try to develop the various formulas using all these three contents. From this concept we can calculate the weight also. So if you want to calculate the weight of the substance in grams, then send the molecular mass this side. So number of moles into molecular weight in grams. Let us see another formula. Weight, N value. When number is given, sometimes they give the number of the particles, but they ask us to calculate the mass. So when number is given, N value means this value. So in the place of N value, we can substitute this form. So here we can write down that given number of particles divided by 6.023 into 10 power 23 into molecular weight. Now let us see. If they give the volume of the gas, then in the place of N we can write down the volume now. So here we can write down that given volume of the gas divided by 22.4 liters into molecular weight. Let us try to solve simple questions using these four formulas, then we shall go there. So first one is, find the number of moles present in (54 grams of aluminum. Atomic mass of aluminum is equals to 27. Then formula. Here information is given in the mass. Since mass is given, use the mass formula. Weight by molecular weight. So that number of moles equals to weight given mass is 54 grams. Atomic mass is 27 grams. So this value is equals to 2 moles. Now let us see. If moles are given, how to calculate the mass? Find the mass of 2 moles of magnesium. Atomic mass of magnesium is equals to 24. Then the formula for this is, we need to calculate the mass. Information given is mole. So this formula helps us. So weight equals to number of moles, 2 moles into atomic mass. Here we have taken the molecular mass considering that molecules if given. If atoms are given, you have to take the atomic mass like this one. So it is 24. Total value equals to 48 grams. So let us see this formula, third formula. If number of particles are given, so find the mass of 3.01 into 10 power 23 number of CO2 molecules at STP. So we need to calculate the mass, but number is given. This formula helps us. So weight equals to given number of particles 3.01 into 10 power 23 divided by Avogadro's number, 6.023 into 10 power 23 into molecular mass of the CO2 at STP is 44. So it goes 2 times, this goes 22. So this value is equals to 22 grams. Now let us see if volume is given. Find the mass of, so volume, let us take 11.2 liters of O2 at STP. So solution for this is weight equals to given volume 11.2 liters is given. STP volume 22.4 liters into molecular mass of the oxygen, that is equals 32 grams. So it goes 2 times, is equals to 16 grams. So like this we can calculate the number of moles when mass is given. If other values are given, like number of moles is given, we can calculate the mass. Number of particles are given, we can calculate the mass, and when volume is given also, we can calculate the mass of the substance or the molecules. Now let us try to solve the questions using this one, and we shall develop the similar type of the formulas here also. So I want to calculate, already n is there, number of moles. When number of particles are given, number of moles can be calculated using this formula. Sometimes they will ask us to calculate the number of particles. Number of molecules or particles. Number of molecules if they ask, then n into 6.023 into 10 power 23. But in some exams, some questions what they give is, they give the molecule, but they ask us to calculate the number of atoms in that particular quantity of the molecules. Then this formula is not helpful. Then we have to use we have to add the atomicity also. Then number of atoms. Number of atoms in a given molecule is equals to n into 6.023 into 10 power 23 into atomicity. For example, if you take the H2 molecule contains the 2 hydrogen atoms. So here we have to use the atomicity of the H2. If you take the ozone, 3, like this atomicity has to be used. When they ask the atoms calculation by giving the molecule. If they ask only molecules by giving the molecules, then atomicity is not required. Directly this formula is helpful for us. Now, in the place of n, now I am not following this formula now, we shall follow this formula. So, in the place of n, what type of information we can substitute? So, number of molecules or particles. So, sometimes they will give the mass, but they ask us to calculate the number. Mass means n means already we have seen weight by molecular weight. So that we can substitute here weight of the substance divided by molecular weight into 6.023 into 10 power 23. And number of molecules calculation. So if volume is given, but asking us to calculate the number of molecules, then in the place of n substitute that formula. So that here it is given volume in liters divided by 22.4 liters into Avogadro's number 6.023 into 10 power 23. So let us try to solve the questions using these 5 formulas. 1, 2, 3, 4, 5 formulas. So first one, calculate the number of moles present in 12 into 10 power 23 number of ammonia molecules. So solution for this is N. So already number is given, asking the mole. So number is given, asking the mole. This formula is helpful for us. Given number 12 into 10 power 23 divided by Avogadro's number 6.023 into 10 power 23. You take the approximate value. If you make it round figure, it gives automatically 6 value. Because it is 0, no, you can neglect it. So it goes 2 times. This cancel out. So the answer is nearly 2 moles. So let us see the second one. So in the second one, let us see the calculation of the number of molecules. So calculate the number of molecules present in, let us take 1 mole, 2 moles, let us take 2 moles of CO2. So solution for this is number of molecules is equals to, given is 2 moles into 6.023 into 10 power 23. That is 12.046 into 10 power 23 number of CO2 molecules are present. Now, let us see here, third one, calculate the number of atoms, this one, number of atoms in 2 moles of CO2. Similar question I have taken, but here we calculated the number of molecules, here we are calculating the number of atoms. So number of atoms, solution for this is number of atoms means CO, total atoms in the CO2 molecule equals to, see this formula, number of moles, 2 moles, Avogadro's number 6.023 into 10 power 23. Each CO2 molecule is having 3 atoms because 1 carbon atom and 2 oxygen atoms. So like that it is equals to 3. So 3 into 2 equals to 6 into 6.023 into 10 power 23 number of atoms are present in the 2 moles of CO2 molecule. Now let us try to solve the questions on this number of molecules when mass is given and when volume is given. So fourth one, find the number of molecules in 44 grams of CO2. So solution, so number of molecules equals to, given mass 44, molecular mass also 44 into Avogadro's number 6.023 into 10 power 23. So it cancel out, finally it is giving the 6.023 into 10 power 20 the number of CO2 molecules. Now let us see this formula. Find the number of molecules present in 5.6 liters of NH3 gas at STP. So solution for this. So number of molecules is equals to, given volume 5.6 liters STP volume 22.4 liters into 6.023 into 10 power 23. It goes 4 times and it goes 1.5 approximately. So 1.5 into 10 power 23 number of ammonia molecules are present in the 5.6 liters of ammonia. So like this we can solve the questions when number of particles are involved in a particular formula. Now let us try to calculate the number of moles when volume is given, and calculation of the volume when number of moles are given, when number of particles are given, when mass is given. So let us try to see here. Calculation of number of moles when volume is given volume by 22.4 liters at STP. So this is applicable only for the gases, not applicable to the any other substances. Solids and liquids, it is not applicable. Only for gases it is applicable. That too at STP condition it is applicable. Why? Because we have taken the 22.4 liters. This is the volume of 1 mole of the gas at STP. So now let us try to see calculation of the volume. So volume of the substance in liters can be calculated. We send this value the other side. So 10 into 22.4 liters. And volume of the substance when number of particles are given. When number of particles are given, in the place of n, we can substitute this formula. So given number of particles divided by Avogadro number 6.023 into 10 power 23 into 22.4 liters. So when mass is given, how to calculate the volume? So volume in liters, in the place of n, we can substitute weight by molecular mass. So write down here weight by molecular weight into 22.4 liters. So let us try to solve some simple questions using these 4 formulas. So first one is calculate the number of moles of 11.2 liters of CO2 at STP. So formula N equals to given volume 11.2 liters divided by STP volume 22.4 liters. Cancel out so that it is 1 by 2 means this value equals to 0.5 mole. Next one, calculation of the volume. So find the when number of moles are given, find the volume of how many, let us take 3 moles of O2 gas at STP. So this is volume in liters is equals to given number of moles is 3 and the value is STP volume 22.4 liters. So this is equals to 67.2 liters. Third one, calculation of the volume when number of particles are given. Calculate the number of molecules. Sorry, they ask the volume, we have to calculate. Calculate the volume of 3.01 into 10 power 22 I am taking. Number of O2 molecules at STP or O2 gas at STP. So solution, volume in liters is equals to given number of particles 3.01 into 10 power 22 and Avogadro's number 6.023 into 10 power 23 into volume is 22.4. So it goes 2 times and it goes 10 power minus 1 time. So this value goes 11.2. So this is equals 11.2 into 10 power minus 1 liter. Or else you can write down this one as a 1.12 liter. So now let us try to see here another formula. Calculation of the volume when mass is given. Find the volume of 32 or let us take 16 grams of O2 at STP. So that solution for this is volume is equals to in liters, given mass 16 grams, molecular mass 32 grams into 22.4 liters. Goes 2 times, it is 11.2 liters. So in this way we can solve the questions on the mole. So I hope you understand. Let us try to take one more example to make the mole concept even more easy for us. So the question is, which of the following is having maximum mass? So let us see here. Options are given. 27 grams of aluminum, half mole of silver, next 3 moles, or else let us take the 44.8 liters of O2 at STP, and fourth one 12 into 10 power 23 number of H2 molecules. Our intention is to calculate the mass, but the given information is in the various forms of the mole, except this one already 27 grams is given. So here not necessary to calculate. Half mole is given. We know how to calculate the weight. When mole is given, weight equals to number of moles into atomic weight now. What is the number of moles? It is 1 by 2. Atomic mass of the silver is 108. So 108 by 2 is equals to 54 grams. 44.8 liters of O2 at STP. Then weight equals to given volume 44.8 liters. STP volume 22.4 liters into molecular mass of the oxygen 32. So it goes 2 times. This is equals to 64 grams. Next weight. Given number by Avogadro number into molecular mass. Given number 12 into 10 power 23 divided by Avogadro number 6.023 into 10 power 23 and molecular mass of the H2 is 2. So it goes 2 times. So 2 into 2 equals to 4 grams. So which is having the highest mass here? That is 44.8 liters of O2 at STP. I hope you understand this concept of mole. If you have any doubt, please do write us to the classroompoint@gmail.com, and please do not forget to subscribe the channel. And we will make a separate video on the objective part of this mole. For all the concepts, objective part shall be in the separate videos. Only theory part in one type of videos, this type of videos, and objective part will be in the another type of video. Thank you all.